This is how latent space actually works, or at least how we talk about it without immediately pretending there is a dream world inside the machine. There is not. No glowing inner cinema, no secret gallery, no little digital landscape where ideas wander around wearing tiny philosophical coats. Latent space is a mathematical representation space, a hidden space where a model represents patterns, features, and relationships in compressed numerical form. That is the clean version. The less clean version is this. Latent space is where the machine stores the shape of things without storing the things themselves. Not the cat, the catness, not the faceness, not the sentence. The structure, tone, meaning, and relationships that let the model place it near other things like it. During training, a model learns to transform raw input into internal representations. Text becomes tokens. Tokens become vectors. Images become arrays of numbers. Audio becomes signals. Everything human gets dragged into math because that is where the machine lives. As the data moves through the model, each layer transforms it. Early layers may capture simple features, edges, textures, word fragments, basic relationships. Deeper layers may capture more abstract patterns, objects, styles, concepts, tone, intent, similarity. The faint smell of a marketing department trying to sound authentic. These internal representations exist in latent spaces, hidden numerical spaces where information is compressed and organized by learned relationships. That is why latent means hidden, not magical. Hidden. Latent space is not usually something you look at directly. It is not sitting there as a neat map with labels like dogs, sadness, cars, regret, and LinkedIn thought leadership. It is high-dimensional, messy, distributed. A coordinate in that space does not usually mean one simple thing. The meaning is spread across many dimensions, which is inconvenient if you were hoping for a tidy little diagram with an arrow labeled vibes. But distance and direction can still matter. Things with similar features often end up represented near each other. Changing position in latent space can change the output. Move one way and an image becomes more smiling. Move another and it becomes older. Move another and suddenly the model has invented a chair that could not survive gravity but seems very confident about it. This is especially visible in generative image models. They often start with noise or a compressed latent representation, then gradually transform that representation into an image. The model is not pulling a finished picture from a drawer. It is moving through learned structure, turning coordinates, noise, and conditioning into output. That is why latent space feels like imagination. You can combine ideas, interpolate between them, blend styles, move from one image concept toward another. Ask for a purple dinosaur eating ice cream in space, and the model can generate something because those features exist as learned patterns that can be combined inside the representation space. Not because it dreamed, because the geometry allowed it. Now, latent space and embeddings are related but not identical. An embedding is often a specific vector you can extract and compare, a location. Latent space is the broader hidden space where representations live, shift, combine, and get transformed. An embedding is an address. Latent space is the city, a strange city, no zoning laws, too many dimensions, occasional hands with 7 fingers, but still a city. Latent spaces also compress information. Compression is powerful because it captures what matters and throws away what does not. At least what the training process decided did not matter. That is both useful and dangerous. Because when a model compresses the world, it also inherits the biases, blind spots, and weird priorities of the data and objectives that shaped it. The latent space is not neutral. It is a map drawn by training. And every map is also an argument about what matters. So how does latent space actually work? A model transforms raw input into hidden numerical representations. Those representations organize learned features and relationships inside high-dimensional spaces. Similar patterns often land near each other. Moving through those spaces changes what the model generates or how it interprets input. Latent space is not imagination. It is compressed structure, a hidden geometry of learned patterns where the machine can combine, shift, and reconstruct pieces of the world without ever having lived in it, which is not magic, But from the outside, with the lights low and the output good enough, it is easy to see why people get confused.